All right, hello everyone. I wanted to take a few minutes to go over some notes that we're going to be covering in class this week. And it's going to start off with the question, what does it mean to solve a right triangle, or any triangle for that matter? And the example is, in triangle ABC, angle C is 90 degrees, B is 25, and side C is 18. So solve the triangle. And these are the only directions that you're given. And what does that mean? That means to find all sides and angles. That's what it means to solve a right triangle. So here we go. Well, first let's draw this. Well, triangle ABC. It's going to be a pretty generic triangle for us. And C is a 90-degree angle, and this is the A, and this is the B. This will be pretty standard. There'll be different letters, but when there are different letters, just draw out your different triangle. Make sure you know which one is the right angle. And B is 25, so we're going to put 25 there. And side C is 18. Well, this doesn't have a side C on it, but what C means is directly across from the C side. So this would be an 18 out here. And this is an A angle, so this is an A side, and this is a B angle, so this is a B side. All right, so what are we left with here? Well, we need to solve it means we need to find all the sides and angles. Well, this is 90, and this is 125. So we know that a triangle has 180 degrees, so 180 degrees minus the 25 and minus this 90 gives us 65 here. So we're done with one step of the problem. We figured out what this missing angle was. We knew this one, this one's missing. And these are complements. These always add up to 90, so that's another way you can do it. Now we have to find the sides. Well, we know this is 18 and this is something here. We're not sure what it is. And the way we're going to get that is with our trig ratios. And if we call this theta, and that's our choice, we can call whatever we want theta. You can call this theta or theta or theta. It does not matter. But we're going to call this theta. You want to pick one of the acute angles. Don't pick the right angle here. And we call this theta, then I know that the sine of theta, which is 25 degrees, is equal to the opposite side, which is B over 18. So I have that set up right there. And now I can use this to solve this equation and figure out what B is equal to. All right, well, let's solve for B. And if I cross multiply B times 1, let me go ahead and circle these here. The cross multiplying works that these multiplied together are equal to those. So this is B times 1 is B, and then 18 times sine of 25 degrees. So now all I have to do is do the math, and let's see here. Well, do we know what the sine of 25 degrees is? No, it's not on a unit circle. So I'm going to use my calculator and make sure I'm in degree mode and type in 18. Whoops, let's type in sine of 25 degrees. So we have 18 times 0.4226, but this is a irrational number, so we want to change this to about. And if I do 18 times 0.4226, comes out to be B is about 7.6068. We're going to round it to 1 decimal for this assignment. So now we figured out this side over here is 7.6. All right, one bit of advice here. Instead of doing all of this rounding here, we can just jump straight from this step to this step by typing in our calculator 18 sine 25 degrees. And then we can skip all of this, writing this down here, and just jump right to there. All right, now that we found this side, the only thing that's missing here is this angle. Well, if I use my same logic, well, this is theta, and this would be adjacent to it, so the cosine of 25 degrees is equal to 8, or A over 18. Cross multiplying, you'll start to get really fast at this. After you multiply it, it's just 18 times cosine of 25 degrees. That can be punched in your calculator, 18 cosine 25 degrees. And this side is A is about 16.3 centimeters. This one was centimeters. This one is centimeters. So we can put that here. And now what we've done is we have solved this triangle. Let's see here. Do we know the angles? Well, we have a right angle, a 25-degree angle, and a 65-degree angle. We know all the angles. Do we know all the sides? Well, we have an 18 side here and a 16 side there and a 7.6 side there. This triangle is solved. We have all the measurements. 2 ways to check it. Number 1, do this check over here. Make sure that they add up to 180 degrees. 65 plus 25 plus 90 definitely equals 180 degrees. And check the sides. A squared plus B squared equals C squared. I did the math earlier. This side comes out to be 323.45, and this one comes out to be 324. Those are very close, just off by some rounding because we rounded here and here. All right, last problem we want to do. This is a book problem here from the homework for this week. I'll go through this with you. Page 196, number 19. It says the sun is 25 degrees above the horizon. Find the length of a shadow cast by a building that is 100 feet tall. Well, the key to these problems is setting up a picture, and they've given you this picture here. We have a building, the sun, this angle up from the ground to the sun is 25 degrees. That's an angle of elevation, and we want to find this side. So let me redraw this over here. And this is 25 degrees. Buildings are built at right angles, and this is 100 feet tall. And we're missing this side right here. Try to draw your pictures to scale. This is definitely a 25-degree angle. So if this is the building over here, this shadow is going to be longer than the height of the building because of this angle right here. So that'll be a good way to check our answers at the end. All right, let's go ahead and figure out this side here. Well, we're only going to get to sides and angles by trig ratios in this class. So what do we know about this? If I call this theta, I'm dealing with an opposite and adjacent. Opposite and adjacent. Well, hey, that's in our saying SOHCAHTOA, that is a tangent ratio. So we have the tangent of 25 degrees is equal to the opposite side, which is 100 over our unknown. Let's solve this. We have x times tangent of 25 degrees is equal to 100. Divide both sides by the tangent of 25 degrees. Not on the unit circle, so I'm going to use a calculator. 100 divided by the tangent of 25 degrees is about 214.5 feet. Does that make sense in our scale drawing? If I take this 214 here and I put this in this place, this is 100, well then that's definitely close to 200. If you draw your pictures to scale, you'll be able to check them that way. All right, I hope this helps.